Good afternoon. My name is Karin Habshi, and I'm going to give you the GMC 555 course. It's a design course. We will interact together to work on design projects, and we will introduce different engineering concepts in this course. So first, I will go briefly over the syllabus before we start the first chapter of our design course. So mainly, this course is a course for the BE in Mechanical Engineering, and it will prepare you for the capstone design course and the final year project. So it is designed to develop the heat and transfer fluid dynamics fundamentals that you already know, but we will see them more in engineering applications. So we will integrate all our knowledge to be able to come up with, to design a complete project from A to Z. So this will give you the opportunity to design a mechanical engineering thermal system by solving complex problems associated with energy, engineering economy, manufacturing, sustainable design, and optimization of energy efficiency for thermal and fluid systems encountered in mechanical engineering work. So we will have a theoretical part in this course. For example, we will learn how to design uh, tubing systems, piping systems. We will see how to, what are the standards and what are the constraints that will allow us to select the pump size, for example, the size of our tubes, etc. So this will be a theoretical part to show you how we can do a design on a certain engineering project. And then for your project, you can suggest any topic that interests you, or I can give you a list of topics and you select the one that you like. So this is our purpose at the end. At the end, you should be able to design your own project for an engineering system. Now, concerning the delivery of the course, so now we start online, so hopefully after we can meet on campus for more interaction. But I will try my best to give you all material needed, even if live online classes are not possible if we have electricity cuts. So we will have interaction together with live sessions when possible. When not possible, I will post for you material and I will record for you lectures so that you can go over the course material and not be late.
دكتور بس سؤال حنضل زوم على طول.
هلا مبدئيا I am fixing Microsoft Teams. It was not working today, okay? So I will fix it with the IT because my password and were not working. So we'll see why. And then we can move to Microsoft Teams if you prefer.
اوكي ماشي ميرسي.
Okay, anyway, all lectures will be recorded and they will be available for you. Okay, so I will post them on a YouTube list and you can access them anytime you want. Now, concerning the design activities, so as we said, the purpose first is to develop the method of investigation and the topic of the thesis. So you will exercise an informal description and exploration of the topic. So this will help you to frame the issues and to study the beginning of the research. So we will learn how to do research because for any new topic, you have challenges. You have to fix something. So the first step to do, as we will see in the design process, first we will define the problem. And then once we know what is the problem, we should try to find a solution. And the solution, we cannot find it directly. We should go to, we should do a small literature review to know, in general, what engineers or what scientists can do in such cases. And sometimes you cannot find directly the solution in literature, but at least you can gather information and develop your own knowledge, which will help you into solving your specific problem. So this type of research is very important, and we should go through it in this course. So this will include a full literature search. So you will go back to maybe journal papers, books, or sometimes, of course, experiments already done in the same field of your problem. So you can know what in general is done in such cases. And as we said, if it's a completely new problem, you can benefit from other experiences and apply them on your own problem. So this will introduce you also to do a research proposal planning, which will help you after into performing your assessment. Okay. Now, concerning the different topics that we will go over in this course. So first, of course, as the name of the course indicates, it's a design course. So the first step will be an introduction to the design process, and we will apply it for engineering mainly. And then we will move to energy economy, we'll introduce it, and we will see what is the time value of the money, how we can do a decision at the end, because whenever you are designing, you will have several alternatives. You don't have one choice at the end. You will end up with many possibilities to solve your problem, and it's up to you to select the better option. And to be able to select, you should develop some criteria that will help you into the selection. So let's say you will consider the cost, you will consider the efficiency, you will consider several aspects that can affect your project. And then you can put a certain scaling, a certain grade for each solution. And then the highest grade you obtain will tell you that this is the better solution I can do. So we will see how to do this. And also in engineering economy, I will introduce for you a method to assess if a project is profitable or not. And sometimes you find a solution and you say it will solve my problem, but it might be the cost might be very high. So in case you will lose money, you might say, no, I don't want to go through this project. So one of the methods is to of the economical methods is to do the life cycle assessment and to find the net present value of the project. So all of these terminology will be familiar for you when you go through these chapters. So by doing so, it's like you are doing the balance between costs and benefits, so you can decide. And what is very important in economy is the time. So you cannot say $100 now is like $100 after 1 year. So with time, the value of the money will change. So the time value of money is a very important concept in economy, and you should take it, of course, into consideration when you select a solution, because this solution should be on the economical level should be profitable, because one of the main important aspects in design at the end, of course, we care for a good design, we care for having a safety measures, we care for everything related to engineering, but at the same time also the economical aspect is very important. So this is for chapter 1. Now in chapter 2, I think you are all mechanical engineers, yes? Or we have different backgrounds? All of you are mechanical. Anyone is not a mechanical engineer? Okay, so mainly in this chapter, it will be a small review for you. Of course, you know all of these. So we will go maybe in brief over unit systems and conservation laws applied for fluids in the thermodynamic field, because this course is a combination of several disciplines. So as the name indicates, is design of thermal and fluid systems. So you will need thermodynamics, you will need fluids to understand your problems. So any problem you might face will combine several engineering disciplines. So in the courses you have taken before, each course will work on a certain aspect, but in design, you will combine several courses. So it will be, you will use all your knowledge in one project. You can use thermodynamics, you can use fluids, you can use optimization, mathematical tools, you can use coding, of course, MATLAB, you can use computational fluid dynamics, CFD. Maybe, I don't know if you have already taken a CFD course. If not, I can introduce it to you a little bit. We can learn how to draw, if I have a certain problem, let's say I have a mechanical ventilation system and I want to optimize its design, how to do it. It can be very complex to think about writing our own MATLAB code for such complex issues. So whenever I have complex geometries and I want to study the variation of, let's say, temperature, velocity, concentration in the space, if you are interested in indoor air quality, let's say, Now, it's a very important topic currently because you have corona and you might need to reduce contamination as much as possible. So you can design, let's say, a ventilation system that can protect occupants from contamination. So all of these can be simulated by computational fluid dynamics. This science consists of taking the famous Navier-Stokes equations, which you know from fluids that it's very hard to solve them. And the researchers searched a lot for analytical solution, but they were not able to find it. So for the majority of complex engineering problem, we should go to numerical analysis. So we will transform these differential equation into algebraic equations by using, for example, the finite volume technique. You have or finite elements in order to solve for this. You will write your numerical equation, one for temperature, one for velocity, one for concentration. Of course, it will be very hard to do it on your own. This is why there's a lot of softwares that are based on computational fluid dynamics. So just you should understand your problem. You should know your boundary conditions. What I mean by boundary conditions, the inputs that you should impose on your system. So let's say you have a ventilation system. You should know what is the heat loads generated by occupants, by, let's say it's an office, by computers, by lighting, by the heat fluxes coming from outside. So it will depend on the envelope of your building, on its level of insulation, on the U values of the wall. So all of these will be taken into account when you draw your geometry. And when you set for your boundary conditions, so let's say you can impose what is the inlet temperature, what is the flow rate needed to be supplied to the space. So you can conduct a parametric study to optimize the performance of your system, or you can propose to assist the conventional system with a new one. So this is design. Okay. Now, in the third chapter, we will go over computerized solution of type 1, 2, 3 problems and minor losses in series pipe networks. Already in fluid mechanics, if you remember, you have taken, whenever we have turbulent flows, okay, the solution of these problems becomes very complex. And we introduce the Moody chart, if you remember. And the solution in general is done by iteration process. So we will try to gather in this chapter to write codes instead of doing this manually. So in fluid mechanics, you were used to solve such problem by using Moody chart and using the main equations governing the fluid flow. So what we will try to do here, we will review these equations and we will try to write MATLAB codes in order to solve for these in a more efficient way. And in addition, we will introduce a new concepts. So for example, in fluids, you work in general, let's say, with one diameter for the piping system. So what will happen, let's say, if I have a sudden change in diameter, so I should deal with two parts. Then instead of having just one friction factor, I might have two, F1 and F2, and the number of unknowns is increasing, which will complicate the solution of this. This is why we need to implement, let's say, a more complex technique to solve for such cases. And we will focus on pipe in series. Of course, you can have pipe in parallel, etc. But in this chapter, we will consider pipe in series, and we will learn how to solve for these unknowns. Then in chapter 4, we'll introduce parallel pipe systems and the design work associated with them. And we will start also to conduct in parallel with the fluid mechanics analysis, the economical analysis. So in general, this will always help you into the selection, into selecting the optimized solution, because you will see that sometimes the number of unknowns is more than allowed. So you need another criteria to add. Okay, so this can be by the selection of the proper diameter that will reduce the cost. So in chapter 4, we will do an analysis for a parallel pipe system, and we will see how, using the economical criterion, we can close our system of unknowns, if you want, because we will have several possibilities, and to select one, you need another criterion, which will be the economical one. In chapter 5, we will see also a continuation of the idea of economical diameter. So we will have another approach, and we will go for pumps performance and pump selection. So in general, it's very important to know how to design a piping system, because at the end we should know what are all losses we are going through in order to be able to know which pump to use and what should be the capacity of this pump, what should be its characteristics and its performance. So all of what was done before will lead us to an appropriate pump selection. After, we will go over simulation of a system of pump with ducting system, and we will study pump cavitation, pumps in series and parallel. So sometimes we can use several pumps. One pump might not be enough. And we will go over dimensional analysis and the affinity laws. So in this part, mainly, we will be working with pipes and tubing and pumps. Then we will move to a heat application. So we will go to heat exchangers. We have several types of heat exchangers. So we will describe them. We will know the difference between them. And of course, also it's a design process. So which type to select, based on what, etc. We will continue then the analysis of heat exchanger. We will see, already you are familiar, I think, with LMTD and NTU types. Anyway, we will do a review of these types. And we will also study condensers and evaporators. After this, we will introduce double pipe systems, shell and tube systems, plate and frame, cross flow, fluid flow measurements. So all of these you will are very important, because you will use them practically in your work as mechanical engineer. And after this, of course, we will try to start before, but at the end, you should present your design project work. But you will start with this. You'll try to start with this early so that you have enough time to work on your design project and present. Okay, so at the end of this semester, you should present your work, and of course, during the semester, we'll have tests, and at the end, we will have a final exam. Any question on this? Okay.
Doctor, we
Yes.
need to form groups.
Yes, of course, we need to form groups. Of course.
How many?
It can be maximum 3, 2 to 3.
Okay.
Okay. And also, we might select a very big project and decompose it into parts. Also, this will be great, because this will, if you want, it will help you into doing a connection between several groups, because higher the number of teams, in general, the projects you will face after are very big and complex. So it's not enough maybe just to have 2 or 3 persons working on it. So sometimes we divide a certain project into several parts, and then we connect and we do interaction between the groups to come up at the end with the final design. Okay, so we'll see. We will see what are the ideas you will suggest, and I will suggest for you ideas, and then we'll see if we do a big project or we go to small projects, so small design projects. So if anyone has an idea in mind and want to propose it, feel free to propose it anytime you want. You can send me an email. And also, if you want, we can create a WhatsApp group for the class so we can communicate easily in this way. So the main, one of the main objectives in this course is to develop your ability to work in team. So the teamwork is very important, okay? And you should be, you should help each other, and each one should do its own work. So don't rely just on one person in the group, it's bad. So the interaction between you is very important, and everyone should perform its own work. So what we will do, as we said, we will try to assemble and apply the thermofluid and heat transfer principles to model thermal components. So in any project, you will have several components, and sometimes you need to study each component alone. And after this, one strategy of optimization consists of dividing the system into parts, optimize the performance of each part, and then assemble the system. And of course, once you assemble it, also there is a challenge that maybe someone might tell you, if I optimize each component alone, maybe if I assemble them, it will not be the optimized solution. Yes, it might be true. So you have different approaches in design. Some consider that it's a good strategy to optimize each component alone, and then take the optimized parameters and apply them when they are assembled. So the different parts are assembled. Other consider that no, it's better to work from the beginning on optimization of the whole system. So both, nothing is right or wrong because nothing will work always. Okay, but with experience, you will know which projects are better to solve with this approach and which one are better to use with the other approach. And then we should know also how, after we come up, let's say, with a certain solution, we should analyze it and make sure that it's working. Because sometimes maybe you will do a hard work and do everything you can to come up with a solution, but at the end, the solution will not work. And this is bad, of course, but this is design. So you might need to reiterate and repeat until reaching your desired level. And of course, one very important parameter is economical analysis. So maybe you can design a very, let's say, in the field of car design. So you can design the most beautiful car in the world, but you need a very high cost to come up with this car. So you might not go for it. So the economical analysis is very important. And of course, we will see how to perform optimization, which can be analytical and numerical. You can combine analytical techniques and numerical techniques in order to evaluate the designs. And of course, this course will help you to develop your writing and communication skills. These are very important skills for engineers. So you might be a very good student with very high grades, but if you don't have good writing and communication skills, you will suffer in work. So you should work on yourself to develop these skills. Now, concerning the textbooks, we will mainly, we will have several references, okay? The main one, we will try to follow the outline of Jana, which is a book on design of fluid thermal systems. So the name of the book is as the name of our course. So you will find very interesting information in this book. I advise you to do some readings from time to time. It's a very interesting book. And also, you have several other references that can help you through the design process. You have Bejan, which is thermal design and optimization. You have Hodge analysis and design of energy systems. You have Wilbert, which design of thermal systems. And you have also Introduction to Thermofluid Systems designed by André Garcia. And the fifth reference is Design and Optimization of Thermal Systems. So all of these references can help you in designing your project. Now, concerning the grade distribution, so mainly you will have homework. So homework part will be on 10%. We'll do 2 mini projects. They can be coding projects. Okay, so I will tell you that, for example, for computerized problem of type 1, 2, 3, which will use, instead of using Moody charts, you will use empirical relation, and you will write the set of equations, and use the iterative procedure to solve for a certain fluid problem. So projects in general will be about coding, and we'll have the participation and discussions together. You have 10% on it. We will conduct 2 tests on 25%, and for the final report and presentation of your design project is on 30%, and the final exam will be on 15%. Okay, so this is in general for the syllabus of the course. Any question before we start the first chapter?
نعم دكتور.
No.
معقول نحن نقدر نشتغل على الاف واي بي تبعنا لانه بيشمل كل هول اللي قطعوا معنا وانا والبارتنر هون بنفس الصف يعني هيك بنكون هو بروجكت ضخم بنكون اشتغلنا عليه منيح.
Look, I will ask Dr. Nimr if this is possible. I don't have a problem with this, but I don't think you can do it because you have an FYP لحال and the course لحال. Anyway, I will check with Dr. Nimr if this is possible.
Okay, مش.
But in general, look, maybe because the FYP in general it's much you need to perform much more work and load for the FYP. So I don't think that the project we'll select here can be suitable for FYP. But if it's accepted by the administration, I don't have a problem.
هو هيك لانه بيكون هو بروجكت ضخم كثير فعم نشتغل 3 اشهر بيكون نفس البروجكت.
طيب, let us see. We'll talk about this, okay?
Yes, okay.
Okay, so now to start with the design process. So in this session, we will introduce the design process in general. Then we will consider the engineering design process. You know that design did not miraculously appear, but they originated in the minds of human beings and took time to develop. And engineering is a creative process of turning abstract ideas into physical representations. So just when we say engineering is related to design, because from definition of engineering, it consists to turn the abstract ideas into physical representations and as products or systems. Now, if we want to define design, we can say that it is the process of originating and developing a plan for a new object, a new system. And it will, of course, require brainstorming. We should define first the problem, then perform research on it to be able to know, in general, what other people do. Sometimes some people say we can skip this step, but in reality, this step will help you a lot because you will learn from mistakes of others, okay? So the design will require research, thought, and modeling. You should think a lot before you start because this stage will help you a lot into gaining time after. In addition, we should do interactive adjustments. So as we said, it's an iterative process because we might not from the first trial reach the desired solution. So we should always adjust, and sometimes we should redesign. We should start sometimes from zero. Now, what are the main steps of design? So if we want just to summarize in brief, we have these 5 steps. We should define first the problem. We should gather information, then generate multiple solutions, then analyze and select a solution, and finally test and implement solutions. Now I will go through each part and detail. Okay, so to start with, when we say we should define the problem, so what do we mean by this? Who can give me an example?
For example هلا الايسيات مثلا بيعملوا صوت بتقطع الكهرباء فينا نستعمل محلهم راديو كولينج.
Okay. Look, in general, it's fine. when you define the problem in general, first, you do not use technical words, okay? And you do not directly propose solutions. So as you said, the first sentence you said is very good. So let's say HVAC systems are producing a lot of noise. This is the definition of the problem. Now, so,
Yes.
okay? Now, once you have defined it, you will search for solutions, okay? And you can have several possibilities of solutions. One of them is the one that you propose. Okay, what's your name?
Okay, Joseph. Joseph Tyrus.
Okay, Joseph. So first, let us say technically, okay, what is the step of defining the problem? So first, in any project, you need to begin the solution to a design problem with a clear definition of the problem. And the definition of a design problem may evolve through a series of steps. So you might start with a certain definition, but it will little bit change after as you proceed. So because as we said, the design process is iterative and all of its steps will be iterative steps. So we might go back again to these steps or alter them and change them depending on the evolution of the project. Okay. So more you develop your design and you have a clear idea of it, then better will be your understanding of the real problem. Now, the second step is to gather information. And as we said, it's a very important step because before you can go further in the design, you need to collect the information available that relates to the problem. So as we said, maybe some designers will skip this step, but in general, it's not good to skip it because you will learn a lot from it. And instead of, let's say, doing the same mistakes of others, then you have to repeat from zero, you will avoid all of this loss of time. So it's true that you will lose some time to find information about your topic and have a complete idea of it, but after it will save your time. Okay, so gathering pertinent information can reveal for you facts about the problem that result in a redefinition of the problem. So sometimes maybe while doing your research, you say maybe I didn't define appropriately my problem. I need to change something or to redefine it completely. So this is why we said that even the definition of the problem might evolve during the design process. Now, once I did my research, I went through literature and I have a good idea about the topic, I can move now to the phase of a generation of solution. So, and I will not search for one solution. You should always have alternatives because, as I told you, sometimes a certain solution might seem very good, but on the economical level, it's a failing solution. So I cannot go for it. So a main idea here is to develop multiple and not only one solution. So the next step in the design process will begin with creativity. You should be creative. This is engineering. Okay, you should come up with new ideas, original ideas. So sometimes you can face a problem that is completely new. So you can profit from literature and you can join several systems or several research ideas to be able to reach your new solution. So creativity is very important in this step. And when we say creativity is much more than just a systematic application of rules and theory to solve a technical problem. So, and you can be creative. Maybe you can say it might be difficult, okay? But creativity just starts by the decision of taking risks and by combining maybe several ideas done before, but when you combine them in a new way, it's creativity, it's something new, and it's an original solution. Now, next we move to the step of the analysis and the selection of the solution. So once you have conceived alternative solutions to your design problem, you need to perform the analysis of these solutions. And then you will decide which solution is best for your design project. And the analysis is the evaluation of the proposed designs. So you might propose several designs, and you should perform analysis of them. How to do so, we will go in detail over this. So you will apply your technical knowledge to the proposed solutions, and you will use the results to decide which solution to carry out. So at this step in the design process, you must consider the results of your design analysis. So let's go back to the problem of the HVAC system, and we want to optimize it. Okay. Here, for example, you need to simulate your space. You can do CFD simulations, and you should do analysis of your results. So in CFD, let's say you can implement all the solutions that you thought about. So let's say you want to use radiant cooling, for example, or you say, no, it's better to use personalized ventilation, or let's say to replace mixed ventilation by displacement ventilation. So let's say you want to enhance the performance of your HVAC system in terms of indoor air quality, and you start to propose several solutions. So now, after this step, here, you should implement all, you should simulate all of these ideas to be able to do the analysis of the results you get in order to select the most appropriate solution among the ones proposed. Okay? And then, here sometimes, of course, it requires a lot of experience. What the purpose of this course is to give you the first step. Okay? So you are when you go to the work, you will see that with experience, you might directly select the appropriate solution, or you will have a more critical thinking to know which one can be the best option. Now, once this is done, we go to testing and implementing the solution. So the final phase of the design process will be implementation, and it can be done by testing your solution. So you can do it by testing, constructing. Let's say you come up with a design. Okay, you should manufacture this design, and you should come up with your final product and have it to be. During the process, you will test it, and then to come up at the end with the final product you design. So, of course, to do so, you should go through several methods of implementation. You should construct a prototype first, maybe, and then before completing your final product.